this apart?
I think we first have to get, I would first get the exponent out of the parentheses.
Okay, but that's not what we did first back in this problem. If you look back at what you wrote
Oh,
down,
yeah.
log base 5 of 25 plus log base 5x squared, that's law one. All
Okay.
right, so I'm just asking you to basically replicate everything we just did here, which is, it's a lot, but the first step here is to break apart the product into a
So it'd be
log.
log
Good,
base 2 of 8 plus log base 2 of y to the power of 3.
good, good. And then the goal here, game, is to figure out, was there a way to write 8 as 2 to some power? Is there a way to rewrite the 8 as 2 to some power like that?
2 to the 2 to the third.
2 to the third. Okay, and so that's where we proceed from here. Log base 2, 2 to the third, plus log base 2 of y cubed. Now you can apply that third law where the exponents come out in front.
So that'd be like log 3.
Nope, let's go back and look what we did here. What am I showing here with this arrow and this arrow? And then where did the
Oh,
exponent go in the next line?
you're showing me that the exponents are going in front of the log.
That's what law 3 says. It says that exponent out in front. So tell
Okay.
me what to write next. What comes next here
3
when you do?
times log base 2 of 2 plus 3 log base 2 of y.
Good. Now, is there any other simplifications that you can make here?
Mm.
What about when the base is the same as the argument? Base is the same as the thing you're taking the log of.
That would be 1, right?
That'd be 1. So what does this first term become?
So it would be 3 times 1, basically.
Or just 3? Like that. All right, you ready to try one here on your own?
Yeah, I'll try.
All right, so let's say it's log base 10 of 100 y to the 4th. Go ahead and give that a try. I just want your final answer. This part, so work it as far as you can, and let me know what you come up with.
Okay. Okay, so far I've gotten 2 plus 4 times log base 10 of y.
That was the correct answer. Good. Really good. Okay, so the law that we have not really touched today is the middle one. And it's I'm gonna snip it in here. We'll look at some problems like that. So here is that middle one. It says a quotient on the left here. It's really division. Quotient means division. M over n equals log base b of m minus log base b of n. Basically, you take the top, the thing in the top, subtract the thing in the bottom. Okay, so we'll look at a couple of problems like that now. Let's say it's log base 9, 729 over x to the 5th. Okay, this becomes log base 9 9 x to the 5th. All right. Now, could you look and see if there's a way to write 729 as 9 to some power?
No, I haven't, but I can check right now on Desmos.
Great. It's good to know these exponents. They'll come up again in standardized tests, and you want to be quick with them.
It would be 9 cubed.
It is 9 cubed. Good. So the only difference, right, the quotient becomes that. You still write log 9 cubed minus log base 9x to the 5th, and then you move those exponents out in front. So 3 times log base 9 of 9 minus 5 times log base 9 of x. This one on the right, on the left here becomes 1. 3 times 1 or 3 minus 5 log 9 of x. Okay.
Got it.
All right. So let's look at another one here. Let's say it's log base 4 of x to the 8th slash, because this is how your class does it, 256. Okay. So just like before, it becomes log base 4 x to the 8th minus log base 4 256.
Okay.
So does 256 come? Is it possible to write as become? Does it become 4 to 10? Like, what is that number?
It's 4 to the 4th power.
4 to the 4th, yes. So this is log base 4 x to the 8th minus log base 4 4 to the 4. Lots of 4s over here. That's okay. In both cases, we're going to bring that exponent out in front like that. 8 log base 4 x to the 8th minus 4 log base 4 of 4. 1 on the right becomes 1. 4 times 1 like that. Oops. Got those 8s. I didn't mean to put those in. Any questions on that before I have you doing?
No, I'm good with the questions.
Okay. All right. Let's say it's log base 5 x to the 10th over 6,125. Sorry, that's not right. I gave you the wrong number, 3,125. Okay. Would you try this one on your own, please, and just give me the final answer?
Yeah. Can you go back to the example for real quick? Because it didn't. I just need to double check something.
How are you doing on this one?
Good. I just need to go back to the example problem just to double check something.
Okay.
Just want to make sure I'm doing the steps correctly. And so, yeah. Could you use on OneNote, just scroll up a little bit because I didn't have time to. But yeah, thank you. Okay, thank you. You can go back down.
Okay.
So the answer would be 10 log 5 to the. Wait, sorry. 10 log base of. Oh my god, I can't say it.
You good? You're doing good. You said 10 log base 5 of, and then
Of
what's the
x.
next thing? Good.
Yeah.
Anything else?
No.
What about this one right here? This doesn't go away. Like in the
Oh.
previous problem, we had a number here, right?
Oh yes. Sorry. It was adding so plus 5.
Okay. So it doesn't sound like you got this expanded quite right. Minus log base 5 of 3,125, like that.
Yeah.
Do you have something like that written down?
Yeah.
Okay, that's good. What is 3,125? How can that be rewritten as 5 to some power?
It's gonna be 5 to the 5th.
Okay. So lots of fives again.
Yep.
What can we do with the exponents?
We put them right in front of the log, which we would multiply.
Okay. So that's how you got the first term.
Yeah.
So what happens to the next term? What is this? What does all this become on the right?
Oh, I multiplied negative. Oh, it's negative of not positive. But okay. So it'd be 10 log base of 5 of x minus 5.
Yes. Good.
Got it.
Okay. So let's we're gonna keep working on these, but I'm gonna show you some other properties. Let's say it's 5 log base 2 x times y times z. Okay.
Mm-hmm.
So this 5 in front, it's really multiplying everything that's in here. And the part in brackets, this is really law 1. It's a product, so it becomes a sum. Log base 2 of x plus log base 2 of y plus log base 2 z. So all I did here, took the product becomes the sum.
Uh-huh.
That's law 1.
Okay.
Now I'm going to bring this 5 down. And then this 5 distributes into everything. So this 5 gets distributed to each of these. becomes 5 log base 2 of x plus 5 log base 2 of y plus 5 log base 2 of z. That's just the distributive property. Any questions on that?
No, I don't. No, I don't have any.
Do you have these laws like in front of you written down? Or do you
Yeah.
want me to put them? Okay. Because it's kind of like you gotta have them next to you the whole time to be able to do problems. So here's one I'd like you to try. 6 log base 3 of x times y. I'd like you to simplify this for me, please, just like I did in the last problem.
Okay. Okay, so it would be like 6 log base of 3 of x plus 6 log base of 6 log base of base 3 of y.
Yeah. Don't get
Uh,
caught up on the words.
Yeah,
If you're telling me the right things, I'm gonna write it. Really, the words are not important
yeah.
in this
So then
case.
so plus 6 log base 3 of z, or
Well,
no
there's no
z.
z. There's no z.
Yeah.
There's no z. Good, good. Okay. So now let's say there was really an x squared and a y cubed here.
Okay.
Okay. Now we know that the exponents come out in front, right?
Yeah.
But what we haven't said is, well, what's the math operation? And it's multiplication.
Uh-huh.
So you bring the 2 out in front, but you're multiplying. This becomes 12 log base 3 of x. Bring the 3 out in front, 3 times log base 3 of y. Sorry, 3 times 6 log base 3 of y. So it becomes 18 log base 3 of y. So you bring the number out in front, you bring the number out in front, and you multiply.
Okay.
Is that clear?
Yeah.
Okay, because I'm gonna have you try one now, and I want you to ask me any questions, or then you take the product and it becomes a sum, but you give that 6 to both of them, and then you bring the exponents down and multiply.
Okay.
All right, so let's go 4 log base 7, x to the 9th, y to the 10th, and we'll leave it like that. Go ahead and give that a try, please.
Okay. So it would be like 36 log base 7 of x plus 40 log base 7 of y.
You got it. Very good. Really, really
Ooh,
good. Okay, now we can make these just a tiny bit more difficult here. Let me try them. Let me do this. So 3 log base 10 of now, let's say x to the 9th, y to the 5th, like this. This becomes 3 log base 10 x to the 9th minus because it's a quotient in here. Like think of this as a big subtraction symbol. 3 log base 10 y to the 5th. And now we can do the same thing. We can bring that exponent out in front. So this becomes 27 log base 10 of x minus 15 log base 10 of y. So it applies not just to the products, it also applies to the quotients.
mm-hmm.
Does that make sense?
Yeah.
So here's another example problem. Let's say I put a -2 in front because I can really put anything I want there. And what if I do this? X to the -5, y to the -10. Okay, I can have negative exponents. That's no big deal. This is a product inside here. So a product becomes a sum. This becomes -2 log base 3 x to the -5 plus -2 log base 3 y to the -10. Now, what do I do with these exponents?
What do you do with the exponents? Oh, well, you multiply them to the -2's.
That's right. So this becomes 10 log base 3 of x plus 20 log base 3 of y.
Yep.
It doesn't matter. What if the exponent could be a fraction, it could be a decimal, it could be anything. You can still multiply the front.
Got it.
Okay. So here's one for you to try. Let's say it's -3 log base 4 x to the 12th y to the -9th z to the power of 1. Why don't you try this one on your own, please?
Okay. Okay, so it would be -36 log base 4 of x plus 27 log 4 base y
Why?
anyway
Of what? Good.
of y
Keep going.
minus 3 log base 4 of z.
Really good. Really, really good. Okay. We're almost up to kind of the most difficult problems you'll see. This is fantastic. So a couple other things that you might see in here that we haven't done in a while. I'll do a couple of examples. Let's say it's -5 log base 6 of 1 over 36x squared. Okay.
Okay.
This is kind of new. I'm going to work it out here, but this is new, but it's something you might see. And after this problem, maybe we'll transition to something else. So it's still a quotient. Like, even though there's no variables on the top, there is a number. So it is a quotient. It's -5 log base 6 of 1 minus, okay, I'm sorry, let me do this differently. So I want you to see this is in brackets for the moment. It becomes log base 6 of 1 minus log base 6 of 36x squared.
Okay.
It's the top minus the bottom. And that -5 is still on the outside. We'll get to that in a moment here. On the right here, this is a product. Okay, it's a product. So the product is 36 and x squared. There's really, I'm going to do this in blue to make this, there's really another set of parentheses here. So this becomes log base 6 36 plus log base 6 of x squared. That's all in blue here. And then I'm bringing everything else down.
Mm-hmm.
Is that okay so far?
Yes.
All right. Now, this negative has to get distributed to both. So this becomes log base 6 of 1 minus log base 6 of 36 minus log base 6 of x squared. Now, I know this has been a lot for this problem, but I want you to notice something. The thing in the numerator was a 1, and it's positive. The denominator of 36 and an x squared, 36 and an x squared, and it was negative and negative. So the things in the top are positive, the things in the bottom are negative. But now we have this -5 that we can bring out. So we have -5 log base 6 of 1 plus 5 log base 6 of 36 plus 5 log base 6 of x squared.
Got it.
Is there any way to write 36 as 6 to some power?
6 squared.
6 squared. This is 5 log base 6 of 6 squared plus 5 log base 6 of x squared minus 5 log base 6 of 1. What can we do with these two exponents over here on the right two terms?
We can multiply them by 5.
This becomes 10 log base 6 of 6 plus 10 log base 6 of x. Do you remember what log of 1 is always? Log of any base of 1, what that becomes?
It would. No, I actually don't.
So this part is 0.
Okay.
It's another property. How about log base 6 of 6? What does that become?
Log base 6 of 6 would become 1.
It's 1. So this becomes 10 times 1 plus 10 log base 6 of x. 10 plus 10 log base 6 of x is your final answer.
Oh, okay. Got it.
All right, so let's not do one like this. Let me transition to solving some problems. So let's say I had log base 3 of x equals log base 3 of 2x minus plus 3. No, sorry, I gotta get this right. Sorry.
Are you gonna say -1 at first before you change to the 3?
Yeah, I gotta make one that works here. Let's go 2x minus 1. So this, I believe,
You're gonna give me a no solution problem.
yeah, I don't want to do that. That's bad. So when the logs are the same, log base 3, when the logs are the same, you can set the inside part equal to each other. Okay, so we're just totally transitioning out. No more of those properties for the moment. We're just solving logarithmic equations. So could you solve this for us, please?
Yeah. So for this one so far, I haven't gotten the answer, but I've gotten log base 3
No,
of
you're solving this equation down here.
oh I am okay.
Yes, this right here becomes this because the logs are the same. Because the log base 3 is the same in both, you set the inside parts equal.
Okay, that makes more sense.
Okay, you set x equal to 2x minus 1 equal to 2x minus 1.
So x equals 2x minus 1.
You need a reminder on how to solve equations like this.
Don't worry, I got this.
Okay.
I think. I'm gonna try my best. I got 1/3.
Okay, that will definitely just a quick review of this. So the goal is to get all variables on one side.
Mm-hmm.
So there's choices. You can either subtract 2x from both sides, or, and I'm just gonna put this over here on the left. That's option 1. And it just kind of depends how you learn this, or you can subtract x from both sides. Do you see it one way or the other, the left or the right?
No,
Okay,
but
so the
yeah.
way on the left is kind of the more like traditional approach, always moving the variables left, which is fine. Okay, so can you tell me what 1x minus 2x is?
That would be negative 1x.
Negative 1x, good. Equals negative 1. So when we say solve for x, what we mean is to get x completely alone, no number in front, not even a negative. How can you undo a negative? Do you remember from a previous course?
How to undo a negative?
Yeah,
I was gonna. Don't you have to? You would have to mul no
yeah,
multiply it by a
you
negative.
or divide by a negative, either one. Multiply or divide by negative 1. So on the left, this becomes x equals 1 on the right. Okay, so good news is you're going to get plenty of practice here working on these in the next 10 minutes here. So let's take a look at another problem here. So when the logs have the same base, and these have the same base, when they have the same base, you can set the part inside parentheses equal to each other.
Okay.
All right.
Okay, I'll
So
try solving.
to solve this, I would recommend moving the 2x to the left. Okay. So I'd like
Okay,
you to subtract 2x from both sides and then divide both sides by whatever numbers under the x. Give that a try, please.
sure, I'll try. I got so I did that. So it would be 3x equals 9, and then I divided
Okay,
by 3. So the answer is x equals 3.
good. Very good. Okay, that's fantastic. So here's one I'd like you to try on your own, please. It's a little
Okay.
bit different, but hey, let's just see. This is all review once you do the thing we talked about, which is to set because the bases are the same, you can set the parts inside equal to each other. So go ahead and try this one. It's a little bit different. I want to see if you got it or we need to do some review on equations.
Okay. I got k equals 2.
Okay. K equals 2 is correct. Good. All right. So now a
Yay.
slightly more difficult one. All right. So give this one a try, please.
Okay. Yeah, you're right. This one is difficult.
It can be done. You have to set the inside parts equal. Tell me what you're doing first to solve this.
Um, I first I think I'll add 3x to the negative
Okay.
4x.
Okay. That's fine.
So
Now,
that'd be
unfortunately, yeah, 10, what does it become?
um it becomes negative x. So
Negative
minus
X equals 10. Good. Now the ten over here is positive. It's
yeah.
remember the sign, the operator comes to the right. This is positive, although not written. So how do you undo plus 10?
How do I do what?
How do you undo plus 10? How do you move
Mine.
plus 10? Yeah, subtract 10.
Yeah.
So you have negative X equals 0, which is fine. That, maybe you don't like it, but it's fine. I mean, it's okay.
Yeah. Is that the final answer?
Nope, we have to get X by itself. You have to undo this negative.
Okay, so that means we're dividing by -1,
That's right.
which
So
means
X
x
equals,
equals still 0.
good.
Ah, lovely.
Okay. Let's try another one here. It's kind of the same type-ish. So we're going to start seeing different types of answers now. They may not always be whole numbers. They might be fractions. They might be negative. Again, if the logs are the same, and we don't even know, but let's just say it's log base 3. I'm just making that up. You can always set the inside parts equal.
Got it.
Give this one a try, please.
got a equals -1, so I must have done something wrong.
Why do you think that? Why, like, tell me, give me some more information. You got a equals -1, but why do you think that it's wrong?
I think it's because I likely confused myself somewhere because I originally moved n- um 7 to 9, and then I was like, no way, that I don't know. Is it right?
It is correct. Yeah.
Okay, then why did I doubt
But
myself?
I get concerned because I think, well, what are you seeing where you say, oh, I did it wrong, and it's okay that it's negative. I mean, it's not the worst thing in the world.
That's true.
Just sometimes the answers don't look the way you want, which is good. Okay, so the next type of problem that we are going to look at is and we won't have time for you to do any examples, but I'll just kind of start the process here. Let's say it's something like log base 2 of 4x equals 1. Okay. This
Okay.
time there's not a log on both sides. Okay. Not good. We don't like that, but that's what it is. To undo a log, you use the base. So this has a base of 2 right here. So you write 2 and a 2. That's the base. Log base 2 of 4x 2 to the 1. So notice I basically wrote exactly what was here, except I used the base as the base here.
Okay.
And on the left here, it just undoes it. So the left side becomes 4x. The right is 2 to the 1 power. What is 2 to the 1 power?
2 to the 1 power is just 2.
Just 2. Divide by 4. X equals 1/2. Okay. So this is like what I call case 2, where it's a log equals a number. The first, all these other problems we're doing were like case 1, where it's log equals log, and you just set them equal to each other. All right, we're going to go ahead and stop here for today. Go ahead and stop the recording.
Thank you for
Yeah,
helping
of
me
course,
get
of course.